Okay, so this is a non-homogeneous equation. Okay, meaning the zero function is not a solution to it, meaning that we've got, this is not, whoops, that's not zero on the right-hand side, basically. If we have all of the u stuff on the left-hand side, on the right-hand side, we get something that's not zero. Okay, the initial condition, not the initial condition, the Cauchy data is on the x-axis. And so that's another interesting thing about this problem. The initial data, or the Cauchy data, is zero. And if we're dealing with a homogeneous problem, and if the Cauchy data is zero, doesn't always lead to interesting things. But this is a non-homogeneous problem. Okay, whoops. This is the y-axis, or the x-axis. Okay, so this is the x-axis. This is the y-axis, okay? And what do we know? We know the solution along the x-axis. We know that along the x-axis, the solution is equal to 0. Okay, so x dot of s, again, it's the thing that multiplies the x derivative. So that's 1. X of 0 is equal to some generic point x naught. Y dot, that's the thing multiplying by the y derivative. So that's going to be equal to 1. And then y naught, y of 0 is equal to 0 because, again, we want the x naught, x of 0, y of 0 point to lie on the Cauchy curve. And then z dot of s, well, remember, as always, z dot of s is equal to this part right here. It's equal to just the part that kind of has to do with the derivatives. So that's z dot. So then z dot is, so if I rearrange things, the u goes over there, but u is equal to z, so this is minus z plus e to the x plus 2y. Z to the x plus 2y, and z of 0 is going to be equal to u of x naught y naught, which is equal to 0. Okay, so notice now, z, the differential equations for z involves x and y. Okay, the differential equation for z involves x and y. Okay, now, luckily, the equations for x and y don't involve z, so I can solve the equations for x and y, and then I can use those to solve, then they'll be known, and when I plug them in down here, I can solve that equation for z. Okay, so x of s is going to be equal to s plus x naught. Y of s is going to be equal to y of s is just going to be equal to s. Okay, so the characteristics are going to be straight lines, so I'll just draw a few characteristics. Characteristics are going to be straight lines at a 45-degree angle like this. I'm just going to draw 2 of them for now. Okay, and again, for a fixed characteristic, z of s is the value of the solution along this characteristic, and so I want to solve this equation. So z dot of s is now an ordinary differential equation, and it's going to give me the value of the solution at any point along that characteristic there. So I want to solve this. Z dot of s is equal to minus z plus e to the x plus 2y. But I know what x and y are now, so I can write this as z dot of s, and I'm going to move the z, so this is going to be z dot of s plus z of s is equal to e. Okay, so x is s plus x naught, y is s. So if I do x plus 2y, this is going to give me 3s plus x naught, or I'm going to write this. I think it might be a little easier to deal with to see what's going on. This is e to the x naught, e to the 3s. Okay, so now this is a integrating factors problem. The coefficient on z is 1, so the integrating factor is just going to be e to the s. On the left-hand side, we're going to have z of s, e to the s prime. And on the right-hand side, we're going to get e to the x naught, e to the 4s. And now if I take the integral of both sides with respect to x, or s, I mean, if I anti-differentiate with respect to s, on the left-hand side, I'm going to get z of s e to the s. And on the right-hand side, well, when I take the antiderivative with respect to s, I'm going to get e to the x naught divided by 4 times e to the 4s plus a constant. And now if I solve this for z of s, I'm going to get z of s is equal to e to the x naught over 4 e to the 3s plus c e to the minus s. And now I'm going to use my initial condition, z of 0 is equal to 0, to figure out what c is. So 0, so 0, I thought I had another page here, so 0 is equal to e to the x naught over 4. If I plug in 0 to 3s, that's just going to be 1, plus c, if I plug in 0 to s there, that's equal to 1. So this tells me that c is equal to minus e to the x naught over 4. Okay, and so now I can kind of write this in the following way. So c has e to the x naught over 4, so I'm going to factor this out. So this is going to be e to the x naught over 4 times e to the 3s minus e to the minus s. E to the minus s. Okay, and I'm going to erase this stuff that I have down here in purple. Okay, so what's happening here? Again, if I look at this generic point, I'm going to call this point here AB. If I just restrict my PDE to this blue line here, then the PDE becomes an ODE. And what is it saying? That along this line, it becomes an ODE, and U of AB is equal to Z of S. And this is equal to this up here, e to the x naught over 4, e to the x naught over 4 times this. Okay, so again, if I'm for whatever reason, if I'm just restricting my attention to this one particular characteristic, this is a perfectly fine solution that gives me all of the information that I need to know. But the idea is I want to somehow piece together this information over all of the characteristics and just get a generic formula. E of AB is equal to something that just involves A's and B's. Okay, so I'm going to need to, sorry, my Zoom, I've got stuff in the way of my controls. So I'm going to need to add a page here. Okay, all right, so U of AB is equal to e to the x naught over 4 times e to the 3s minus e to the minus s. Okay, and now I need to figure out what x naught and s are in terms of a and b. Well, this won't be so hard because a is equal to x naught plus s. A is equal to x naught plus s, and b is just equal to s. Okay, so then u of AB. Okay, so x naught is equal to a minus s. X naught is equal to a minus s. but S is equal to B. So this is going to be A minus B over 4 times E. Well, S is equal to B, so this is going to be 3B E minus E to the minus B. And I'm going to write this. I'm going to have the 1/4 out here and distribute the E to the AB. When I distribute it to the E to the 3B, this is going to be E to the A plus 2B minus E, and then E to the A minus B times E to the minus B is going to be A, come on, minus 2B. Okay, and so overall, that's U of AB. But again, A and B are just generic points in the plane, so I'm going to write this in terms of X and Y. U of XY is equal to 1/4 times E, 1/4 times, why is this not working? 1/4 times E to the X plus 2Y minus E to the X minus 2Y. Okay. That's the solution. I will let you, on your own, I will let you verify that this satisfies both the PDE and the Cauchy condition that we have.